So I'm actually really excited about today's class. So I don't know if I mentioned this last time, but we actually somehow managed to get a little bit ahead in terms of the schedule and everything. So I started thinking about, what could I add to the class and things like that, and kind of what topic could I cover. And it occurred to me that, both in previous incarnations of this class, as well as because I actually do have a number of the videos posted on YouTube, one of the most requested topics that I get asked about is what I'm going to talk about today. So it's dealing with recognition still, but AWS Rekognition has the ability to allow you to basically create a kind of private repository of images, of face images, and then basically give it another image to search that particular, what they call a collection of faces, to identify, basically, to see if a person is in that particular collection. Right? So a good a sort of use case of this, we can imagine things like ID badges, right? So each ID badge has an image of an individual. We put all of those in a collection. Then for authenticating, we can do this visually. That is, the person walks up, the camera basically takes a picture of their face, it compares that particular picture to the collection to figure out, basically, is this a known person and who is this particular person. Okay? So that's what we're going to talk about. Part of the reason I think I got as many requests about this as I did is because, unfortunately, AWS does not have a single demo program showing all of this stuff working. Okay? What they kind of have are little bits of code of little different parts and all of these kinds of things, and yeah, it really takes some wading through a bunch of stuff to kind of figure it out. Okay, so what I did is I kind of waded through all that stuff for you. I actually then created a little library, a little module that actually makes it easier to interact with that stuff. And then we'll also look at kind of using that particular library and things like that, look at the code behind it and all of that. Okay. All right, so I'm not going to do live coding today. I've already kind of coded this up and all of that. So just to kind of take a look at a couple of things, right? So the overall structure of this, and the code will be posted, I'm just not going to share the images, right? So here I have a folder named reference faces. And this is where I am storing the individual reference images, right? So I have a couple of images of myself and a few other professors, right? Dr. Gaspar, Dr. Small, and myself. These I basically just pulled off the department website, right? So on the Department of People website, I grabbed the particular images and all that, and basically just drop those in here. Then I have a directory called Faces to Match that I just have a couple of JPEGs that basically have me in them. And the idea is that we will use those to search basically our collection. Okay, so here's the general steps in a nutshell to what you have to do to basically make this stuff work. Okay, so the first thing is AWS's Rekognition has this notion of a collection, right? So a collection basically is the face matching data for a particular image. Okay? Now, sort of sounds weird the way I said that, right? And here's why. So when you add a face to a collection, the raw image data is not stored at all, which is good if you're concerned about privacy issues and things like that. I don't have to worry about somebody basically grabbing those images off the server because the server never has them. Instead, it just keeps the data structure of that image that is needed for face matching to take place. Okay? So all that stuff basically just kind of happens behind the scenes. Okay? So we need a collection. You need to add your reference images to that particular collection. And then you can ultimately search that collection based off of another image. Now, the program that I'm going to show you today does all of these steps in one program. In reality, chances are I probably have separate programs or at least nice functions where, so, because the idea is, look, when I create the collection once. When my program ends, the collection still exists because the collection exists on AWS's servers. Okay? So when I come back, that collection is still there and I can access it and so forth, right? So it might be the case, that we have either a separate program or part of our program where we're saying, okay, create this collection, here's the faces, all of those get added, right? And then we have either another separate program or a different part of that program that basically says, oh, okay, here's an image that I want to search for, or an image with a face that I want to search for, and basically give me the results. Okay. Questions about that? All right. So in the file face_collections.py, I have the various functions for dealing with collections and searching and all of these kinds of things. There's a couple of additional stuff in here. So one, notice we have a file called image loaders. This actually is what did I say it was? Right, so image loaders, notice, used to be named image helpers, right? So this is just the code that we had used previously for loading an image, whether it comes from a URL or from a file, right? Basically, I thought that image loaders actually is kind of a better name for that. This is something that we haven't really talked about so far. This notice this notion of typing, and also, so you'll notice here, if you take a look at this is a little bit different than what we've seen before. So this is what in Python is called a type hint. In other words, what I'm saying is delete collection takes a variable called col name, and that thing is a string. Right here, when we have the arrow notation, right, this is saying that list collections returns a list of strings, okay, etc. So that's kind of how you read these things, right? So you can see, oh, there's a Boolean, right? There, this one returns a list of dictionaries, etc. Okay. So that's kind of how you read that stuff. So notice you can delete a collection. Right? How do we delete it? Basically, we provide the collection name. We can get a list of all of the existing collections, right? We can check to see, does a collection exist? Here's why. Create collection actually uses this because the issue is, if I try to create a collection with a name where a collection with that name already exists, the program dies a horrible death. Essentially, it throws an exception and the program just ends. So my create collection function that I wrote, notice the first thing it does, well, okay, so we create our little client, right? Then we basically call the collection exists function to see, does that collection exist? If it does not, then we actually make the call to create the collection, and then I'm simply doing some testing on the sort of result from that. Okay. Questions about that much? This raise statement, this is basically how you throw an exception in Python. Okay. Right, so we can test whether a collection exists. Also, then we can list faces in a given collection. Right, there it is there. We can add faces to a collection, add a face to a collection by specifying the collection name and then the image itself. Right, find face ID. Find face ID, basically the issue is when you delete a face, what you need to have is the face ID for that particular image. Okay, so findface ID allows us to basically specify the collection and this thing here, X image ID. Okay, so we'll talk about that in a minute. And then there's the findface function as well. Okay, so let's take a look at addface for a minute. Okay. So here inside addface, right, first thing I have actually a nested function. Okay, so Python allows you to define functions inside of functions, right? Basically, it just means that the only code that can use extract file name is code in this particular function. Okay, so this simply does some stuff where whether it's a URL or it's an actual path to a file, it just grabs the last part, right? The actual file name itself. The reason for that is because when we try to, the thing is, we need to store the file name in with the data that we're storing. The problem is, AWS does not allow us to have path separators in there. So all I can do really is just grab that last part. Okay. Again, notice a client gets created, and then we call the index faces method. Okay, so index faces has a number of keyword parameters, right? The first being the collection itself, right? And so that's just the parameter that we sent in, collection name. Then we're specifying our image, right? So we're again using good old get image. And then this part right here. So external image ID is basically a field for us to put some information to essentially let us know later on what image we're dealing with, right? So most commonly, what will be stored here is the file name itself, right? And so you saw, for instance, in my reference images where I basically have each file named by the last name of the professor. So that way it becomes really easy, based off of the file name, I know which person it actually is, it's actually matching. Okay? So that's the idea behind that. That's where external image ID comes in and all of that. Right, so the whole idea, again then, based on, find face ID, right, it takes that same thing, basically the file name itself, then it looks through the list of faces. Here, we can take a look at the code. Okay, notice, not a lot of code here, right? So, we do list faces, right? And then we basically say, okay, if the external image ID is equal to whatever the person entered, or basically the parameter was given to us, then we actually insert that into the list. Okay, so we're generating a list of match results for external image ID, right? And then we're simply saying, all right, check to make sure we got something. As long as we did get something, we just grab the first one and return its image ID. Otherwise, we didn't actually find anything, so we're just returning the empty string. So not a ton going on there. Just to kind of take a look at a couple of these, right? So, here's delete collection. So here, and so you can see, so a lot of my code sort of either borrowed almost wholesale or lightly to moderately edited versions of Amazon's code. This is how exceptions are handled in Python. So on line 22, we say we have a try block, which then ends with an except block. The idea is that delete collection can possibly generate an error, namely when the collection doesn't exist. Okay? So if the collection doesn't exist, then basically we are going to capture that and ultimately raise a particular error. Okay. List collections. Basically generates a list of the various collections, right? And again, let's actually test some of this stuff out. Okay, so if I go here, and I'll say, okay. So right now, I have no collections. Let's create a collection. Okay. So we create a collection called delete me. We call list collections. There it is, right? And I can create. So now notice, I can do this. Right? I still only have one collection called delete me. Again, because we test to see if it exists and all of those kinds of things, right? Let me add another one. Whee! Yep. Oh, probably. I guess it doesn't like that. Yeah. And then notice we do have delete collection that takes a name. So for instance, I could do for call in list collections. So creating collections, we have, all these types of things, we have that stuff. Okay. Take a look at some more of this. Finding a face. So once you have a collection created and you've added faces to that, then you can call find face. Notice we specify the collection name itself, and we also specify the image to find. Okay, so notice it's not really a lot of code, right? We create the client. We call search faces by image. We specify our collection name, and then we simply specify the image in the same way that we had been doing this before when we were using Rekognition. And then we simply return the face matches section of the response. Okay. So let's take a look at this. So up at the top, I got a bunch of stuff going on here. So in the pathlib module that's built into Python, there is a class called path that can be used to easily create platform-specific path separators. So that is, I can define a path, and then basically I can add on the file name, and Python will automatically put in the correct path separator. So on Windows it will use \, on Linux and Mac it will use /. Right? Pprint we've already seen before. Glob we'll talk about in a bit. And then let me actually talk about this notation here. Okay. So graphical utilities basically is this file here. And again, it's mainly code that we've actually seen before, right? So I have one here for creating the pillow image. The main difference here between the previous one that we saw took the raw bytes. Here, what I'm doing is I'm allowing for it to either be a string or the raw bytes, right? So the idea is if we got a string, then basically we're going to get the image, set that to that, and do that. Otherwise, we got the raw bytes themselves, in which case we just do this particular part here. Right, bbox to coords, we saw this in the graphical labels version, right? So where we were drawing the boxes to show the faces, right? So recall, this basically converts the dictionary that has top, left, width, and height in terms of percentages of the overall image width and overall image height into basically, as we can see on line 31, a list that has the coordinates in the right format for us to draw a rectangle on the image. Okay? And then what I did is to extract some of the code that we had from previously to create a draw box function. So you pass along the image, you pass along the bounding box, and it will draw the rectangle directly on that. Okay? So that's the graphical utils module. But what I wanted to show, or what I really wanted to talk about, was this much. So here's the idea, or here's the so recall. So if I import a module using just this syntax here, then anything I want to use from that module, what I have to do right is something like this. So I guess let me just do so it loads it up and so forth. Now, the problem is the module name itself is really long. So not only is it a lot of typing, and admittedly, I mean, if I type GRA and hit tab, it'll probably tab complete and all that, but also it's just going to take up a lot of screen real estate and things like that. Sometimes you will see people do this. Now what this does is it says, take all of those functions from the graphical utils namespace and dump them into our global namespace. In other words, now I can do just this. But there's a couple of problems with that. One, it's kind of messy coding, right? As I said, the criticism basically is it pollutes the global namespace. Here's a good example. Suppose you have two functions with the same name in different modules, right? If I do this type of import, then I've got an issue in terms of dealing with those kinds of things. The other thing is, also, in this case, it becomes really difficult to figure out where that function is coming from when I'm looking at the code itself, right? I would see create pillow image, and then I got to look in this file and say, oh, it's not here. It's like, is that a Python built-in? Does it come from what module does it actually come from, etc. Okay? So. Python gives us the as clause for import. And what that basically does is now it's sort of an alias for that namespace. So I can say GU, create pillow image, right? Actually, just do it. Like so. So we can have the niceties of, yes, we can then figure out where that thing's coming from without having to type out the ridiculously long name. So that's all that's going on with that. Similarly here, right, I'm importing the face collections module as fcall. there are a few things that we will be reusing a number of times. So again, think back to the functions that I showed you. They are, those functions, most of them all require the collection name. So instead of my typing out the same collection name every time and probably screwing it up every time and introducing bugs, I'm just going to create a global variable for that, right? So line 23 says we have a variable called collect_name. It's set to prof faces. That's going to be the name of our collection. Okay. Now, in some programming languages, right, so this is a global variable, right? Oftentimes globals are considered bad. Then we typically talk about having constants, right? Global constants generally aren't as big of an issue. However, Python doesn't have constants at all. But nevertheless, it is a convention when you have constants, especially global constants, to name them in all uppercase. Right? So here at least, when I type that out, I should be thinking, oh, I really shouldn't be setting to that particular variable. But Python doesn't really provide a mechanism to keep me from doing that, right? So we have our collection name, and then basically I have the two directories here, the names of the two directories as well. So, first thing we're going to do is check to see if the collection that we want to create exists, right? So I have a print statement here. So line 34, probably pretty good. Take a look at line 35 though. What the heck is that? It's an if-else statement buried inside a what? So, if you've done C, C++, Java, I think C# has it, there's something called the conditional operator. It is a ternary operator. That is, it takes 3 arguments, right? So what this is an expression that will evaluate to yes in the case, right? So this whole expression will evaluate to yes if it's the case that the collection exists. Otherwise, this whole expression evaluates to no. Okay? So a simple way of, and right, I mean, I didn't have to do this. I could have actually just had a separate if-else statement afterwards, and if you're more comfortable with that, hey, that's fine, go for it. So yeah, that's all that's going on there, right? Then I basically just print out some information. Yeah, we're creating the collection itself, and we call create collection. Okay. Then I have a little, so I have the comment here that yes, faces need to be added to the collection, right? And so here what I'm doing is, I'm printing out the faces in the collection. Now, here's the thing. You might go, wait a minute, why are you doing all this stuff? I mean, if you created the collection, shouldn't there be no faces in it ever? Here's the thing. Remember, because the way create collection was written, it will only create the collection if that collection does not exist. So the idea is, the first time I run this, that collection doesn't exist. And so, for instance, those lines 42 to 44 should show me basically an empty collection. However, a little bit later down in the code, we actually add faces to the collection, which means if I rerun this, now when I get to 42 to 44, I'll actually see those particular things, right? And let me show you this. Let's actually just run this. Right? So creating the collection prof faces, right? And then there is the actual collection itself, right? So we can see that's basically there. So let's move on. So then my code checks the collection. Oh, actually, yeah. Let's run it again. Right? Notice, now there are faces in the collection, right? And prof faces exists as soon as this program is run. Okay? So there's the faces, all of that, right? And so, we'll take a look at the data real quick, right? So again, it's basically just a list of dictionaries. So for each one of these things, notice we have a bounding box for that isolates the face on that particular reference. Right, works just the way we saw before. Yeah, there's a confidence value here, but that's kind of weird. There's our external image ID, right? So we can see that this particular record is for Dr. Small. Okay. Then we have the face ID for that. There's also an image ID for that. And then we go on, right? So here we have Dr. Gasper's record, and then finally here we have my record. Again, just to compare it, right? Notice. First time through, yep, the collection doesn't exist, right? And we can see there, and then when I go ahead and run this a second time, yes, now the collection does exist, right? And there are the faces stored in it. Okay? Questions, issues, etc. Okay. Okay, so how do we put these in, right? So again, line 48, all I'm doing, checking to see, do I have at least 3 faces in the collection? Because I know I have 3 reference images, so I just check. If I don't have at least 3 images, then I go through. Now, here's the thing though. Suppose I didn't have this if statement, and I just ran this code anyways. It'll still work. And actually, it will not duplicate the data. It'll go to add the face, and then it'll realize, oh, this is actually stuff that I already have, and so it will not. So I'll still end up with only the 3 elements in there. Although that still takes time to upload those images, index them, and all of that sort of stuff. So if we don't need to do that work, then let's not do that work. Okay. Here is the path separator stuff. Right, so prior to, I forget which version, but Pathlib is somewhat new. Prior to this, you used the OS path module for doing this, right? So here we create a path object, right? And again, we can take a look at this. So So notice, it tells me it's a Windows path. Right? We recognize that I'm on Windows. There it is. Here's what's interesting, though. What they did to be able to add in parts to the path is they overloaded the / operator. So in other words, all I need to do is that, right? The path, a /, and then that, and so that will automatically give me the correct stuff. Okay, and then we can actually convert that to a string, for instance. Okay. And so we can see here, yeah, I'm getting the proper value, right? The / here. So I create a path for the reference images directory. Okay. And so originally I had hard-coded in the particular values. And that's actually fine, but then I decided, you know what, I actually just want it to automatically load up whatever images are in the reference images folder, okay? So that's where glob comes in. How many people have heard of file globbing? Okay, so in the glob module, there is a function named glob. Returns a list of paths matching a path name pattern. So, file name globbing generally works at the command line, whether you're dealing with Linux, whether you're dealing with Windows. Most commonly, you have the star wildcard, which basically says match anything. Right. So, for instance, if I call glob and I say, yep, faces. That says, find me all the files in the faces to match folder, right? And so we see we have all those, but notice we also have a README file in there, and same thing for the other one. So what I'd like to do is only get those files ending in JPEG, like so. Okay. So I go to the reference face directory, right? And then I tack on the /star.jpg, and so then glob will return just the name of just those particular JPEG file names, right? And then so I actually print these out, right? Here's the list of file names, and we print that out, and then we simply iterate over that list of file names, calling the add face function with the collection name and with that file name. So that will add that to the particular collection, and then once we're done, we print that information out to the screen. So again, just to take a look at that stuff happening. Oh, actually, let's see. Yeah, it's not happening now because we need to delete our collection. There. Right, so here's the list of file names. Right, there they are, Gasper, Small, and Ventura, and then there's the printout of that stuff. Now, I also added in code just to actually display those reference images along with the box information, right? So here, right, again, so basically we're just iterating through the list faces, right, the actual list of faces themselves, right? Then we get the file name, we create our pillow image, we call draw box, and draw those particular images. Like so. Questions, issues, etc. Okay. Once you've loaded up your collection, then you can search for faces, right? So again, here I simply put together the file name itself. So I'm going to load up the Tampa Bay image, right? That's basically this here. Okay, so there's me and my mother-in-law. I think it was like 2 years ago, right? So we want to see if it can actually identify me in this particular image, right? So we load up that particular image, then we just print out some information, right? Then we call the findface function, right? Again, pass along the collection name, pass along the image name. That's going to return this this faces info thing. Okay. In fact, let's do just this. Oh, yes. Okay. fcall. Yeah, it probably would have been easier to just import this, but anyways. There we are. So that's what we get back. We get back, again, a list of dictionaries. The dictionary that we get back, notice we have keys for face and we have keys for similarity, right? For the face, then we have the bounding box, we have our confidence level, right? There's our external image ID. So I can tell now that, oh, Ventura's the one who's actually in that particular image, right? And then it gives us those things. Let me go back to the code to kind of show you what's going on with that, right? So here, right, again, basically get the faces info. Then we say, okay, we found however many things are in the list, and then we want match. Okay. That actually should be yes. Right, and then again, I'm using one of these if statements, right? So the idea is that is basically if there were zero, if there was exactly one face, then we have found one match, right? On the other hand, if there's anything else, we have found so-and-so matches, right? Yep, that's how you do that. Okay. And then I just navigate into the result that I got back, right? So again, we just have a little list here. We basically have a list here. So all I'm doing is extracting from the list the external image ID of each one of those things, right? So we can take a look. We go first to the face field, and then we go to the external image ID to get that. Okay, so this is going to generate, for every face that is matched, we basically get back its external image ID and print that out, right? Which is why then when we run this, okay, we see that. Okay. Let's try the other one, right? So there's another one here as well. And actually, I don't know that I tested this, so we'll see if this works. Ah, it didn't find the duck face one, right? So here's duck, me goofing around. Apparently, it was not able to reconcile this with the reference image itself. Okay, and that actually brings me to a point. So if you look at the AWS documentation for imaging, for guidelines for the images, the reference images themselves, they actually give a number of a bunch of different advice. So the reference images ideally should only have a face in them, right? You can actually have the shoulders, but basically that's it. One person, ideally it should be one person, preferably even kind of centered in the frame. right, etc. Also, bigger's better. You want a high resolution image. And that's actually what I want to point out. This is a really crappy low-res image, right? Look, it's 100. It is 100 pixels by 100 pixels. I mean, it's comically small. And despite that, at least in the Tampa Bay case, it was actually able to match on that. So right there, mad props to AWS, because clearly, you know, and you can see it's kind of pixelated and blurry. I mean, it's a horrible, horrible image. The fact that it works is amazing. Okay. Okay, I've given it a crappy image. That might possibly be why it didn't match the duck face. The other recommendation that they also give is to increase the accuracy. What you would ultimately do is have multiple reference images for the same person. So one sort of straight on, maybe a couple from profiles, these types of things, and then that will increase the chances that it's actually going to match them.